Ladies and gentlemen, welcome to ARPA Data Science YouTube channel. In this YouTube channel, I often give YouTube tutorials, and some data analysis tips. I have more than 10 years of experience in data analysis and visualization and healthcare research. So in this video, I would like to continue from what I presented before about plotting regression models in a forest plot. So I would like to continue the next part of this. Just in case you haven't, if you haven't watched this, maybe I advise to look at the part 1. But today we will continue into part 2. So this is what we did. So you can go and maybe hit subscribe and follow the other upcoming videos. I will also do other videos. But if you haven't watched this, I think I advise that you have to watch this once before you jump into the next part. So if you remember, in the previous video, what we did is we were building a linear model by using life expectancy data from 193 countries, and it has this data. It has about I don't know, 16 or 20 variables. I don't know, 22 variables. So it has 22 variables, and after cleaning and removing missing data, we have about 1,649 observations, and then what we did is we removed missing data, and then we started doing linear models, and we put a linear regression model. Then once we have our regression model, we have viewed the summary of the model, and then after that we extracted the coefficients in this kind of nicely looking table using the GeoTools package. Then after that we have extracted the model coefficients, and then we plotted them using Sjplot too. We put them in kind of forest plot. So today I would like to continue from that. So what I'm gonna do today is I need to first extract the coefficients. And then what we need is we need to retrieve the coefficients, the model coefficients like beta coefficients, and their respective 95% confidence intervals. To do that, because we already have our model, let me remind you. So LM3, I think this was our model. Summary should be double M. Now it should be able to. So now these are the models, right? So these are the coefficients. Because it's linear model, we don't need to change it into odds ratios or something. We just need to extract the coefficients and the odds ratio, I mean the confidence intervals. So to extract the confidence intervals, what we need is we need the conf function. So we just need to do, let me call this coefficient. Let me call this coefficient, and then let me use this conf function, and then LM3. This will extract the coefficients. The next thing is we need to extract the confidence interval. Confidence, let me call it this way, interval. And once you have the confidence interval, you can use confint function. The confint is already there, so you can then call your model. Then this one will export, retrieve the confidence interval. Now the next thing is we need to combine this coefficient and the confidence interval into a data frame. So to do that, conf and confidence interval. I'm just looking the manual way of doing things, doing this. But I mean, there are other ways that you can quickly retrieve or put it in a forest plot. But if you don't want to do it, what you can do is you can extract the coefficients and the confidence intervals, and later you can extract the parameters, or I mean the terms, the variable names. Then you can put all of them together, and then once you have all of them, you can use Sjplot too and and plot them in a simple ggplot. So I use a cbind function so that maybe let's have a look before this and see how coefficient look like. So let's say this is how the coefficients looks like. So it's for each model I have coefficients. I can also round them. Maybe it's great to round. Let me round them into 3 significant digits maybe. Yeah, and I can also round this one, otherwise 3. Then let me check this. This should be rounded now, so you see it's rounded into 3 significant digits. Probably that's too much. Let's put it in 2, and I just change this one into 2. Now if I look this, so it should be in 2 significant digits. So I don't know this, and once I have that, what I'm gonna do is I need to combine the coefficient with confidence interval, what we have here. So I can copy this, and then once I have that, I can pipe it and put it in a data frame. Then once I have that, so I already have the confidence interval in a coefficient, and probably I can add the variable names, the row names. So to do that, I can call my previous data, that's confint, let's say, and then I can pipe it with mutate variable, and then let me call this variable because I want to extract the names, the row names, that's the variable names. Then I use row names, or you can also use names. No, this is row names. Yeah, because it's flipped. So I can use row names. Then once you use the row names, you can call your previous data frame. So you can do this, and I can run this. So now if I have this, if I run it, so you will see the row names, that means the variable names, the confidence interval, and the coefficients. So this is how it looks like. So you see I have the variable names, I have the coefficients, that means the beta coefficient, and then I have the lower bound and the upper bound. Now I just need to do a little bit more data wrangling, because I have to rename this like a lower bound or upper bound, and it should be kind of easy to plot them. Yeah, so to do that, I may have to look at the library of player package, and once I have that, I load that. Let me put it again in confint. Then I can use rename because I have to rename this like 2.5%. Let me call, let's say, the coefficient. Let me rename coefficient into like beta because that's a beta value, but otherwise you can also keep it as coefficient. And the other one is this. I should put it in backtick sign because there is a space, this 2.5 or something. So let me copy this, and yeah, that's then once I have, no, let me reverse, and then you can call your backticks. These backticks, where are they? Let me copy it this way. And yeah, now 2.5% is already renamed into lower bound. The next thing is this 97.5%, then I will call that into upper bound. So let me call this into, because that's the upper bound of the confidence interval. Now, so let's say if I run this, There seems some error somewhere. Unexpected symbol. Okay, rename. Oh, yeah, I forgot this comma sign. And okay, rename. Oh, I need to give my data. Sorry. Conf int, and then C, because I need to put it all of it in concatenate them. I have to concatenate coefficient into beta, and the 2.5% variable name into lower bound, and the 97.5% into the upper bound. So now I need another bracket. Now it should be fine if I put this here. It's just to make it more readable. Yeah. Now if I run it, this should work. Okay, I have loaded it and I think it worked. I just need to see how my data look like. Now I have already renamed, so I have beta, the lower bound, the upper bound, and the variable names. Now let me do something. Let me reorder the variables. Reorder variables. So this is because I want to reorder, the variable should appear at the first, and the beta coefficient, the lower bound, and the upper bound. So I just need to reorder. So this column in reorder, call order. I just need to order that. You can also use a dplyr or something using select or arrange or something, but I just need to create this variable reorder. So the first one should be variable. That means like this. The first one is variable. Variable will appear in the first column, and beta coefficient will appear on the second column. The lower bound will appear on the third, and the upper bound will appear at the fourth column. Now, once I have that reorder group, I can call my data frame and conf int, and then I can call this square bracket, then column order. Here I can copy and put it here. So if I run this and run my data frame, so this should be reordered. I'm just reordering the variables so that they can make more sense. So this is how it looks like. So you see I have variable beta, lower bound, and upper bound. It's just to make it ordered. Then now what I'm gonna do is I need to plot. I need to create my plotting. So to do that, I have to create this plot lm, and then conf int, conf int. Then I don't need the first column. No, I don't need the first row, which is the intercept. I mean, you can put it; it doesn't matter. I mean, you can, but since we didn't plot them in the other plot, I wouldn't also put it in a publication or something. I don't know. Maybe if you are predicting something, you will use it. Otherwise, to put it in your tables or in a forest plot, I probably wouldn't use it. Wouldn't report the intercept. Otherwise, but if you are doing a prediction model or risk estimation or something, then you need because it's part of the equation, especially if it is significant. Yeah. Now I can call my ggplot2 function. So my ggplot, because I already have my data. So then ggplot, and next thing is AES. That's my. Actually, I can type this one because it's easy. I already redefined my data, and then I can pipe it instead of defining the data frame here. So I can simply pipe it here. So you can pipe it, or you can put your data frame just before the aesthetic mapping function. But in this case, I'm just using the PlotLM, and then I deselected one of the observations, first one, because I don't want the intercept to be mapped. And then I just need to define my x and variables, my x and y variables. So within the AES x, I would like to reorder the coefficients by the variables by their own beta value. So for that, I can use variable beta, and that's so x variable is reordered. The next one is what I need is beta. So beta. Then what I need is should be out of the bracket. I need join point. So now if you plot this, what you see would be a simple okay, sorry, and if we run this, maybe no, it doesn't show anything. So the next thing would be defining the points. Within the join point, I should define the size, the shape. Let me put the shape as 15, so it will appear like a like a square. No, not like a square, like a square. Yeah, it should 15 is a square, I think. I mean, you can put it like a triangle or diamond, or there are many, or a circle or something. There are many different shapes. So, but let's choose 15, and the size is equal to let me put it as 4, and the width equals 0.1. And let me create the position, probably in the next position equals Dodge. So if you remember, we were also using this Dodge. It's just to put it in yeah, and then color equals, let me make it black, or you can also choose red or something, but red, I think I will use it for the null point. Now if I run this, okay, width didn't know it, shape width, okay, maybe let me remove it. Okay, let me just do this PlotLM instead, and let's see if that's a problem. Yeah, okay, that's why. So now we have already put the the points. Now what we need is the confidence intervals. The confidence interval. So we already have it. So now if you have confidence interval, it will appear here, and the next one, the next one, the next one, and then it goes until here. So now we have already defined the points. The next thing is you need to add the error bar, and that's the confidence interval. So for that, what you're going to do is you can use geom error bar. That's what you need. So geom error bar, you can define the aesthetic mapping of the y-min. Y-min is the lower bound, of course. So that means y-min will be lower bound, because we already defined it in the beginning. So a lower bound and the upper bound. So this one, the upper bound, I will use it for the next one. And now I can use y max. So I have already defined y min. The next one is y max. So now I have already defined my y min and y max. The next thing is I can define the color, shape, size, those kind of things. So now let me define the width. Let me put it as 0.2. That means how thick the line should be, I think. I think that's also size, but you can also have a look at how they are defined in the Sjplot function. Then position, let me again call that Dodge. That's Dodge thing. And the other one is the color. Color equals I have a color choice. I like this turquoise color, so let me use this turquoise 4, and let me close the bracket, and let's see what is going to happen. Probably I will have some error, so let me close another bracket. Okay, let's have a look. So geom error bar, it is y bound. Okay, this one doesn't need a second bracket, and it should work now. Yeah, now they are flipped. So you know the error bars because the x-axis. So let's say later we will reverse this. The variables will appear on this side, and the beta functions will appear on this part. So to do that, you just add chord flip, and we just need to add chord flip. I think it's here. And just close the bracket. Now it will be reversed. You see the x-axis is reversed into the y-axis, and these are also arranged in a way according to the values. So the negative coefficients are appearing at the far lower left corner, but the positive coefficients, the high positive coefficients, are appearing on the top right corner. Now let me add some other plotting functions, let's say to make it bigger or those kind of things. So let me use this tame and then axis. If you want to make a title, so you can use axis title, and you can define the characteristics of the text. So let's say element text. Then let me make it bold. So it will be face equals bold if you want to make it bold. Then I can add, these are the, how the variables is, each of these variables should appear. So it will be bold. If I change it into bold, they will appear into bold. No, the axis titles, actually this one, this variable will be changed into bold. So let's say if I just use this, the x and y variables will appear into bold. That is it. The next one, let me add xlab because I want to change the labels, because this is a reorder beta or something. I just want to change it into xlab by xlabel, and that would be variables. Let's say this is x variable, by the way. I mean, it's coming from the x variable. I mean, this one, this is x variable, because since we flipped it, this is probably better if you add this function at the very end, because otherwise you might get confused if you are writing, if you are writing your plot function, then you might once you flip, and then if you are adding another variable, if you keep every time you add one function and looking at your plot, and you keep improving or changing the text, how the plot appears, and so on and so forth. So if you have already flipped it, so you might get confused where the x and the y variables are. So to do that, I think I would put this one, the chord flip, at the end, and then do the whole plotting chords at the beginning. So now we have x label, and you can also y lab. That means beta coefficients. Let me call it beta coefficients with 95% confidence interval. Let me just put it this way. Then we can add another one. To do that, we can add, let's say, we want the null point. So since this is a linear regression model, so the null point is 0. So this is our null point. So let me add this geom h line, because as I said, this is the x variable. We will flip it. So I will use this geom h line instead of geom b line. Geom h line. Then let me make the color. Maybe I have to first define the y-intercept, 0, and let me give it geom color. The color color should be, let me put it red, and let me give it a size of 1. It should be fine with 1, but you can also increase if you want a thicker line. So now I have defined my geom edge line, the horizontal line, and probably I can add another theme. Maybe I can add that in axis title. If I want axis title, maybe it's just to make it bigger, you know, how the text appears. So axis title, then once you have the axis title, you can add element text. I think that's it. Element text, and then size. Element text size equals 17, or depending on what you need. I mean, you just plot something and you see it how big it is, and you keep changing it, and until you get your nice plot. Probably I can add one more. Axis text, maybe one more 10. Axis text. Axis text. That's how your text should appear, the x and y axis text. So for that, again, I will use this element text, and I can use size of 14. It's just to make it less than the one we have already defined. Otherwise, they may look kind of pretty boring. So okay, I can write this, and I can ignore this actually, because this is PlotLM. I'm defining the PlotLM. I'm giving it the content. I'm defining the data, and then I'm piping it all together. Finally, I can simply print this plot, and like this. I don't need to add this at the end. So if I run this, it should be possible. Now it should looks like this, but you can also change some of the text options. Let's say, you know, how the variable names are written. Let's say this is schooling, and this is also infant days. It shouldn't be like this when you are presenting it in your paper or something. So you need to change the way these variables are written in your plot. So to do that, what you need is you can add PlotLM. This the one we have already defined. You know, this is our plot, and then you can add scale X discrete. You know, because you want to change some of these variable names. Scale X discrete, and that's here. So scale X discrete, and then you can add the breaks function. I mean the breaks argument. And once you have that, you can define how the variables were written, like this. Let's say school, educational, developing, and those kind of variables were written like this. So you can simply pass concatenated in how the first one is status developing, and teamness 1 to 19 years, alcohol, and so on and so forth. So the next, you want to change it in some kind of text. Let's say you want to change this into like developing country or something. So to make that, you can use labels because you want to label them differently. So again, I will use this C. Let's say first one, I will change it into developing countries, like this. So you see, developing countries, thinness, and alcohol consumption. And so this adult mortality rate was like this, adult mortality rate, and total expenditure, infant mortality rate, and average school years. Now, if I run this, I probably have one error, bracket error. Now it should work. Yeah, now it's working. Okay, still it's not really as elegant as I would want it, but there are other ways of displaying it to make it nicer. But this is a ggplot way of presenting your for Sjplot. Let's say let me make this infant mortality rate instead of infant IMR. So it might not be understandable for someone who is not into this adult mortality rate. Again, you can change it in a way. Yeah, something like this. The next one that I would show you is this is probably the longest way of doing it, but there are also other automatic ways of extracting. So it's like you can use library, and you can use broom mixed, I think. So there is this library called broom mixed, and then once you have that, you can use plot sums, I think, plot sums, and then you can call your model, linear model, and then you can define the scale. You can put it as true, and you can also add some size variable, 3, let's say. Then if I run it, could not function plot sums, broom mixed. So it seems I have it, or it's duplicated. I don't know. Yeah, okay, this should be double M, so that's my problem. Yeah, so it appears like this. Probably there are ways of improving this. I mean, it looks okay, but you have to improve this, the way these variables are written. I'm sure there might be other functions, but if there might be other arguments. To have a look at these arguments, you can just type question mark and then run this. Why is it putting the back tick marks here? Let me put it this way, and you can have, the additional arguments, and you can make it, I don't know, you can make it nicer. You can put the color CUD bright, this is the default, but there should be other other arguments. This is just this is one package where you can you can plot your confidence intervals and in forest plots. And also they have also another function. Let me now we can add a distribution. We can add the distribution of the distribution, this distribution plot on each of these confidence intervals. So what you can do is you can call this again and add some additional arguments. Let's say scale true, size 3, and probably we can add plot distributions, and then let me define that as true, and let's see how. Yeah, so it will be like this. Might give you some idea how the variables are, the distribution of each of these variables are. So it gives you an idea which are normally distributed or something, but I don't know, this might not be useful, but you may, I don't know, if you like, you can use it. And you can also use inner confidence interval. This inner confidence interval label equals 0.9. I think there is this kind of, yeah. And if you want, you can change the color into any kind of color, let's say red or green. Color dot class, I think, color dot class, maybe dark green, like this. So these colors will be changed into this kind of color. The next one, probably the nicest one, that's the one I often use, I really like, is this library, Sjplot. Make sure when you write Sjplot, J is a small letter, but P is capital. So P is capital letter. Now what you can do with Sjplot, it has also nice tutorials. I think it's nice if you Google it. It's from Strinjake. They have nice tutorials. Not here. I think they have one package. Yeah, I think it's here. Not here. Yeah, I mean, you can have a look at the documentation, but they have some blog posts on. Yeah, it should be here, I think. But they have nice tutorials. And you can have a look, and they also have a nice function. Let's say if you want to put your models in, tabulate your models in a table. So what you can do is tab model, and you can simply call your model. So then it will appear in HTML. So it will appear like this. So this will be something you can just copy this and put it in a Word file. Let's say if I put it like this, let me open a Word file and let me show you how it looks like. Okay, Office 368. That's great. Okay. If I put it here and show you, so it will, the nice looking table will appear. So in your regression model, you run your model, and then you can just simply use tab model, and it will appear like this. You just have to change some of these names, otherwise everything is done for you. Sometimes you have to use this cable, this cable, I think cable or cable, I don't know, cable in R. People extract tables using cable function. I mean, it's nice, but I don't know, I find it more complicated than using this tabulate model in Sjplot package. So Sjplot has another function, that's PlotModel, that makes you plot your model in a forest plot. So you can just use plot model and LM3. So it gives you something like this. So it naturally arranges the variables just by default, and what you can do is you can add the values, let's say the confidence intervals or the coefficients. I think to add the values, what you can do is just use show values. It's a simple argument. You can just use show values and run it again. If I run it, so it will show the values. So by default, it's a little bit away from the plot, but you can also make it further. I mean, it's if the number is close to the plot, to this confidence interval plot, you can add a little one argument for that. You can use this value offset. I think value offset, that means you can use, let's say, 0.4. If I use 0.4, it goes a little bit high up. But you can check again and again. So 0.4 is already pushing it high up. So let's say if I use, I think the default should be, I don't know, maybe 2 or 3. Yeah, even 3 it's taking it again high up. So let me put it 2 and check. 2 is okay, but what if I do 1? It seems the default is 1. So I mean 0.1. If I do 0.1, yeah, 0.1 is a bit, it's touching the line, so it might be less readable. So I would put 0.2 or 0.3. So you can use 0.2 instead. And it has also the significant, this asterisk. So if the variable is significant, it's showing you these asterisks, depending on whether the p-value is less than 0.05 or less than 0.01, 0.001, and things like that. We can probably add another value. but let's have another value in instance, like the null point, this one, the null point. I think to do that I will just need to have a look at the functions of, the additional arguments of this function. So let me drag this up. So model group terms type. So because it's also detecting, we are plotting the type, the estimates, but if you want to, let's say, change into RE, or I don't know, I don't actually know what that means. And if you want to remove the terms, some of the terms, let's say, you can also remove some terms, and you can also define the list of terms or variables that you would like to plot. So you can just choose a handful of variables and you can leave the rest. Let's say you want to only display the significant variables, and you can simply display that one. But I needed one, the line. It should be possible. Transform terms sort estimate, by default is true, so it's already sorted, that's why. Group terms, order terms. Axis title, axis label. Yeah, V line. There should be V line, no? Yeah, okay, V line here. So V line color. It's actually putting V line. The default is already putting a V line, because you see there is a white line with a bigger size. We just need to change this V line into some kind of color. I would usually use red color, because that's the null point. So then if I run it, it should appear now. Yeah. So that's how you plot your linear regression models. I will present another I will make another video on plotting logistic regression models, or maybe another, or plotting multiple models. You can also plot multiple models. I think in this case, plot models. So if you have like multiple models, you can also plot like LM1. I think we have LM1, and we did two models, I think LM3. Or we can just, I don't know, for example, just this is for example purpose, we can also put two models. We can plot them, and we have two forest plots that will appear side by side. So the first one is here. Second one will be like this. So two models, they are identical. It's just I was passing two identical models by for each. So you use plot models, LM1 model and model 1 and model 2, and then you can put them like this. Yeah, so they will appear. So you will be able to, let's say if you are doing stratified analysis, so for that it might be useful. Let's say if you are stratifying your data by by gender, for example, for the male ones you do one plot, and then for the female ones you do another. They all appear in one plot, and then you see how one variable is stronger in males or in females than the other one. So you will be able to easily have a look and compare so quickly. So I will do another video, as I said, for plotting logistic regression models. Mainly you want to plot the odds ratios. So for that I will do another video. Keep in touch and please subscribe. Thank you very much. Enjoy R.